Hey guys, today we're looking at compositions of transformations. So we're combining and doing more than one transformation on one graph. So composition of transformations is when two or more transformations are combined to form a single transformation. The result is a composition of transformations. One special kind is called a glide reflection. A glide reflection is first a translation and then a reflection. And there are certain rules about the reflection. It has to be parallel to the direction of the translation. Really, you just need to know that term glide reflection. It may ask you to perform a glide reflection, but then it'll tell you what rule you will use. So in this case, we are doing a glide reflection here, and here's what it'll look like. The vertices of triangle A, B, and C are listed, and then find the image of triangle ABC after the glide reflection. So we're going to start at ABC. We'll find A prime, B prime, C prime by the translation, and then we'll find A double prime, B double prime, C double prime after the reflection, and that will be our final figure. So I'm going to go ahead and plot ABC. So we're right 2, up 1 for point A. For point B, we're right 5, up 3. And for point C, we're right 6, and up 2. So now you're going to have to recall some rules on those reflections and rotations when we get there. But our translation, remember, we just use our original point and add or subtract. So I'm going to take all of my x values and subtract 8, but I'm going to leave my y values the same. So 2 minus 8 would be negative 6, and then I have 1. B is 5 minus 8, so that's negative 3, and then I'm still up 3. And C is 6 minus 8, so negative 2. I'm still up 2. So negative 6 and up 1 is A prime. And then negative 3 and up 3 is B prime. And negative 2 up 2 is C prime. And I'm going to go ahead and dash this since it's an image. So then I'm reflecting in the x-axis, and double prime kind of looks like an 11 up there. It's 2 of those tick marks up in the air. When we reflect in the x-axis, remember that the x and the y stay in the same spot, but the y becomes the opposite. So I leave negative 6 alone, and then y becomes negative 1. I leave negative 3 alone, and y becomes negative 3, and I leave negative 2 alone, and y becomes negative 2. So A prime is at negative 6, negative 1, and it's now A double prime. B prime is now at negative 3, negative 3, B double prime. And C double prime is at negative 2, negative 2. And that's what our figure looks like. So, we're finished there. Your double prime is your final image, and that's the one we care about, is the final one after both of those transformations. The composition theorem says the composition of two isometries is an isometry. So what that means is size hasn't changed, the shape hasn't changed. It's still the same angle measures and side lengths. Okay, so now we have 2 more compositions to do, and this time we just have segment CD. So I'm going to go ahead and draw CD in. It's at negative 2, 6. And that's C, and then negative 1, 3 is at D. Use a straight edge so you're drawing a better line than I am. Now, reflecting over the y-axis. So C prime When I reflect over the y-axis, it's the x that changes. So I have a positive 2 and I still have a positive 6. And for d prime, it's a positive 1 and still a positive 3. So I'm going to go ahead and draw those in. So 1, 2, 1, 2, 3, 4, 5, 6. There's c prime. And then over 1 up 3 is d prime. Now I want you to remember when we're looking at our rotation of 90 degrees, when we used our rotation rules, we switched their places and then we made the first one the opposite. So y, x, and we make the first one the opposite. So for c prime or c double prime, we'll switch their places and make the first one the opposite. For d double prime, switch their places and make the first one the opposite. So we'll go ahead and plot that as well. So -6, 2 is c double prime, and then -3, 1 is d double prime. You'll notice that line segment is still the same length. It hasn't changed. And we actually should have used a dashed line there to show that. Okay, a couple theorems for you. Reflections in parallel lines theorem. It says if lines K and M are parallel, then a reflection in line K followed by a reflection in line M is the same as a translation. So if you look at our original QP, it's been reflected 2 times, but when you look down here at the end, it really looks like it's just been translated over. The same kind of thing, reflections in intersecting lines theorem says if lines K and M intersect at point P, then a reflection in K followed by a reflection in M is the same as a rotation about point P. And point P typically is going to be the origin if we are reflecting in an axis. So the angle of rotation is 2x degrees if x is the measure of the angle formed between the 2 lines that we've reflected over. So just a couple theorems for you to know. If you have questions about any of this, now that we're putting it all together, come in and see me. Otherwise, I will see you in class.